Okay, so radical equations. Our whole goal is to eliminate the equation. But first, let's define a radical equation. So a radical equation is obviously something that contains a radical. So like y equals root 2 plus x. That would be a radical equation. Or a rational exponent. You guys did these in grade 10? Rational exponents. So that would be like y equals x to the 2/3 plus 1. So if we were to convert a rational exponent to a radical, this is actually just a radical hiding in there. So I'm going to erase that line. The bottom number tells us what kind of root we have, and the top number tells us what kind of exponent we have. So if I were to rewrite this as a radical, it would be the cube root of x squared plus 1. So sometimes, like, you're going to have to be able to switch back and forth. You're going to have to be able to see that this exponent is really a radical in a different form. Not the end of the world, but it's definitely pulling it from the depths of your knowledge from grade 10. Okay, so our goal is to get rid of the radical. I'm going to tell you we're going to do these all with squares. Okay, we're not going to do cubes or anything like that. We're just going to do it with squares. You can do it with cubes, but it does get a little bit complicated. So the only thing we're going to accomplish is indexes of 2. So know that we're just stuck with square roots. And what's the opposite to square rooting something? Squaring it, right? You guys have done that a million times in Pythagorean theorem or, solving stuff. So we're going to have square roots and we're going to have exponents of 2. That's where we're going with this. And we know that a squared will cancel out a square root. Okay, so these are the steps. I'll run through them. They'll make no sense. Isolate the radical. So we're going to get the radical on one side of the equal sign and everything else on the other. But we're going to put 2 radicals in there. And then you're going to separate the radicals. One on the left side, one on the right side of the equal sign. Then you're going to square each side. And the purpose of that is to cancel out the square root. That's why we're squaring it. You're going to solve for the variable. And when I say solve for the variable, that's going to be, maybe you're going to factor. Maybe you're just going to do some straight solving with algebra. That is not how you spell solve. I'm going to try that again. It's a good thing I have an erasable pen. You're going to be solving, or you might have to use your quadratic formula. Okay, so when I say solve for the variable, it's like, oh yeah, no big deal. But there's a lot of work that you have to do to get that. And then you're going to check for your solutions. We've seen this before. We know that the square root of 4 is plus or minus 2. And in some situations, we know that -2 won't work, or like, because we're looking for whole numbers or something like that. But what we're going to do is we're going to check the solutions back into the original. So because sometimes when you square something or square root it, you're going to get an answer that's mathematically correct, but doesn't actually work because it's like a restriction, like a non-permissible value. But the square root of 4, square root, so the root would be 2. That's why we call them extraneous roots. Extraneous roots mean like it does not work, and they have to be rejected. Okay, so here we go. First example. Step 1, what am I supposed to do? Isolate the radical. So do you want to move the radical or do you want to move the -3? The 3, right? Like if the radical is already positive, I wouldn't mess with it. So I'm going to add 3 to both sides. So I have root x minus 3 equals 3. Okay, I did a good job there. Step 2, square both sides. Whatever you do to one side, you have to do to the other. So we're going to square this side. We're going to square that side. So this square is going to cancel out this root sign. I just like to draw that line in just to remind myself that they get canceled. So I'm left with x minus 3 here. And then I have 9. And so this one's straight algebra, one-step algebra. I want to get x by itself, so I'm going to add 3 to both sides. So x equals 12. Okay, pretty straightforward. That's nice and easy, training wheels. We're not done this. We have to check our solution to see if it works. So we're going to do the check, and we're going to substitute it into the original equation. So I'm going to have 12 minus 3 equals 0. Root of 9 minus 3 equals 0. 3 minus 3 equals 0. When you're doing your check, you're going to pick the positive principal root. You don't have to worry about the negative 3 there. We're going to go with the positive principal root. So I'm just using the positive 3 here. Is this a true statement? It is, so that's good. My answer's good. Maybe I should write true over here instead of a check mark. Easy? That one wasn't super hard? Okay. So pretty straightforward. So we'll do this one again. Looks almost exactly the same, but and then we got a plus 3 this time. Okay, so here we go. Same sort of thing. I'm going to take that plus 3 to the other side because my radical is already positive, and if it's positive, I'm going to leave it positive. So I'm going to minus 3 from both sides. So I'm going to have x minus 3 equals negative 3. This looks vaguely familiar, but one sign is different. So that's step 1. I've isolated my radical. Step 2 is I'm going to square both sides. So that's going to cancel out that. And I do like to draw that because that helps. And that's going to be a positive 9. I feel like we've done this question before. So then x equals 12. And that's odd that the same equation, or two different equations, are going to give you the same answers, super similar. But now we're going to do our check. So we're going to substitute it right into the original. 12 minus 3. And yeah, I do need to see the checks. So we have 9 plus 3 equals 0. 3 plus 3 equals 0. 6 equals 0. Is that a true statement? That's false. And again, when we do this, we're using the positive principal root in our check. You do not have to worry about the negative one. So we're going to use that positive principal root. So what we do is if this is false, then I go back over here and I reject my answer. So in this case, this equation would have no solution. And we're familiar with that. So that's not the end of the world. So we're going to reject that, and this question has no solution. You just have to state that it's rejected, and that's fine. Okay, so those are the simpler ones. And because, well, I like to torture you, we're going to go a little bit more difficult. Is everybody good with that? Yeah? Okay. Example number 3. What we're going to do, again, we're going to isolate the radical. So I'm going to add x to both sides. So I'm going to have the radical of 2x plus 7 equals, and I'm going to be honest with you, it's just my brain. I want to put the variable first. So the x is positive, so x subtract 4. I don't know why I don't want to put the negative 4 first, plus x. I don't know. You'll get the exact same answer as we go through, but I just don't want to do it. You can't make me. Okay, step 1 was isolating the radical. Step 2 is squaring both sides. So that squared is going to cancel out that root. Okay, so we talked a little bit about this. Oh, geez, when did we talk about it? Like Monday? What do we have to do here? We just can't square both of those. We got to expand it, right? So we're going to have x minus 4 times x minus 4. And so we're going to go ahead and do that multiplying. Are you guys okay that I didn't show like the leapfrogging steps? And if you want to skip this and go right to this, if you can see that, if you can go from here to here, that's fine too. You don't always have to show that step. But we're going to go, I can't stop myself, x times x, and then x times negative 4. So there's my x squared and that 4x. And then I'm going to go underneath, and I'm going to go negative 4 times x. So that's that one. And negative 4 times 4 is that positive 16. By this time, we should be getting really good at multiplying. Okay, as soon as I see that x squared, what do I know I have to do? I'm going to have to factor it, right? I'm going to have to factor to use my quadratic. So I got to set it equal to 0. So that means my x squared is positive. So I'm going to bring the stuff on the left-hand side to the right-hand side. So I'm going to minus 2x. I'm going to minus 7. So I'm going to be left with 0 on the left-hand side, and then x squared minus 10x plus 9. Hopefully I did that right. Everybody good with that? Can I factor this one? Do you see it? Anybody? No? Okay. So the factors, maybe I'll do it over on this side. The factors of positive 9 that are going to add up to a negative 10. They're both going to have to be negative, right? It's the only way a positive factor. So it's going to be negative 1, negative 9. So 0 equals x squared minus x minus 9x plus 9. If you want to do it the quick way of factoring, you're more than welcome to. Look at those two. I'm going to common factor it in x. I'm left with x minus 1. I look at those two. I'm going to common factor it in negative 9. I'm left with x minus 1. So I've got x minus 9 and x minus 1. We're going to solve those. So x minus 9 equals 0. X minus 1 equals 0. So x is equal to a positive 9. X is equal to a positive 1. So that's step 3. That's the solving. And that's just factoring and solving. So that was kind of grade 10, kind of grade 11. There's lots of steps I would have skipped in here. I probably would have went from here to here. Like I would have done that line, and then the answer. Like if I were putting this on my page. So don't feel like you got to do all the steps if you're confident in your factoring, especially when it's a simple trinomial with the coefficient of 1 there. Okay, so step 4 is to check my answers. So 9 and 1. Sometimes you get 4 answers, guys. FYI, that's coming up. And yes, you have to check all 4 of them. And I will tell you, people rush through the check, and it gets not good. Again, there's lots of steps you can skip there. I just want to show all my work. That's just who I am. So that's true. So I know that x minus 9 is a good answer. You don't have to put a check mark by it. It just reminds me that it is a good answer. And now I'm going to check the other one. Okay, so again, I'm using the positive principal root here. And so we're going to have 2 equals negative 4. So that one is false. And so the x equals 1, ooh, I'm doing it over here, is rejected. How do we feel about that? Good? Bad? Not too terrible, but if you rush it, lots of places that things can go wrong. Okay, as per normal, it is never good when I give you an entire page to do one question, because we're going to need the entire page to do it. So, get emotionally ready. All right, okay, step 1 is to isolate the radical. And this time we have 2 radicals. And what I said before is if we have 2 radicals, one goes on the left-hand side, one goes on the right-hand side. And I'm going to move this one here because it's negative. And so all I'm doing is adding root 3x plus 7 to both sides. That's really messy writing, but you'll get the idea. So on one side, I'm going to have root 3x plus 10 equals 1 plus 3x plus 7. Now notice the 3x plus 7 is completely under the root sign. Completely under the root sign. So your root sign should look like they cover everything that's under the same roof. Okay, so step 2 is to square both sides. All right, left-hand side, super easy because I have 1 square root and 1 squared. So those just cancel each other out and I'm left with 3x plus 10. This one is a binomial. You treat it the exact same way that x minus 4 we did on the other side. You have to expand it because it's a binomial. So 1 plus 3x plus 7 times 1 plus root 3x plus 7. Okay, so here we go. You ready? We've never really done this before, but we're going to be okay. All right, so easy one. 1 times 1. Hopefully it's still 1. And then we're going to go 1 times root 3x plus 7, so that's going to be a positive root 3x plus 7. And now I'm going to go underneath, and I've got root 3x plus 7 times 1. Can you guys see that pink? Is that okay? Is that really messing with you? Kind of light? Okay, nobody's screaming, so we'll go with it. And now I have root 3x plus 7 times another root 3x plus 7. So I'm just going to flip back over here for a second. What was x times x? Oh, where am I? X times x. What did we get? X squared, right? So if we're multiplying something by itself, what's another way of writing it? We're squaring it. And what do we know is that a square is going to cancel that out. So really what we're doing is we're taking root 3x and plus 7, timesing it by itself. So really that's like saying it's squared. Anything times by itself, you're squaring it. 4 times 4 is 4 squared. And why do I want to write it this way? Because the square is going to cancel out that square root sign. Okay. All right, I know you're super excited by this. So now I'm going to combine some like terms. So I have 1, I have 2 of those radicals, and then I have plus 3x plus 7, because the square canceled out the root. Okay, I'm not done. I have to start over. I have to start the process over because I still have a radical in here. So I have to start back at step 1, and step 1 was isolating the radical. I know you're super excited. Okay, so all that means is that this guy has to be by himself on either the left or right hand side. And I should keep him, them, I don't know why I'm genderizing some numbers. I should keep it on the right hand side just because it's already positive. I'm a big fan of keeping things positive. So what that means is I've got a -1, I've got a -7, and I have to minus 3x. So minus 3x, oh, look at that. And I have to minus 8. Are you guys okay that I combine the -1 and the -7 into -8? I did that all in my head, everybody. I know you're proud of me. So on this side, I'm left with 2. Okay, so we're back at step 1. We've completed step 1, so we're going to do step 2 now. We're going to square both sides. Biggest mistake I see is although this squared cancel out this root sign, you have a coefficient this time. What do you have to do with the coefficient? You have to square it, right? Because this will cancel out this, but you still have to apply it here. So really you have 2 squared. So you got to keep that square there. People forget about that all the time. And then if this cancels out that, what do you do between the 2 and the root sign? You're multiplying, right? So you're going to multiply by the radicand. So I will say the biggest thing that people forget is that that squared has to apply to the coefficient. And this, people always will forget that you didn't square it and now it's a 2, and that will screw up your entire answer moving forward. You won't lose all your marks, but you definitely won't get the right answer. Well, this is exciting. I know I don't have to factor because there's no x squareds here. This is just a straight solve, 2-step algebra. So I'm going to minus 28 from both sides. Do you guys always put your x on the left-hand side? Yeah, it's just, I totally do too, but I'm trying to be better at doing it through. And so now I only have one answer to check, but here's the thing, is that you may, is it just 2 answers that you get? Yeah, I think you just get 2 answers. But like here, if there was an x squared in this, you're gonna have to factor it and you'll get those 2 answers that you have to check again. So we're gonna do our check on -2. So I'm gonna put it back into the original. So 3 times -2 plus 10 minus 3 times -2 plus 7 equals 1. I'm just going to label this as my check. I'm a big fan of making sure I know where things go. So I have -6 plus 10 minus -6 plus 7 equals 1. So I have root 4 minus root 1 equals 1. I'm using positive principal roots, so I'm not worrying about that negative answer. So 2 minus 1 equals 1, 1 equals 1. So that is true. So that's always great, and so that's a good answer. x equals negative 2. Okay, how do we feel about that? A little bit more complicated, but the whole goal of this is to eliminate radicals from the equation. So if you end up with still a radical, then you've got to repeat the process. And if you have 2 radicals, you're going to do the process twice. I'm not going to give you 3 radicals, just so you know. Okay, there's that rational exponent again. So what does the numerator tell me? That tells me what kind of exponent it is, and the bottom tells me the index or what kind of root I have. And we did these in grade 10, but I mean, that was a million years ago, and we probably did like 1 lesson on them. All right, so here we go. So really, this is the square root of x cubed equals 8. Step 1, isolate the radical. Done, look at that. Step 2, square both sides. And I just want to stress that if this was a cube root, that you would cube both sides, right? Like the goal is to get rid of that radical, and only an index and an exponent can cancel each other out. So I'm going to have x cubed equals 64. And then how do I get rid of an exponent of 3? A cube root. So I'm going to cube root this side, and I'm going to cube root this side. Now, the only answer is 4 with a cube root. With an odd root, you can have negative and positive radicands. So if this was a positive 64, this has to be just a positive 4. It's the even roots that mess with you. For once in your life, even numbers not helping you. Okay, so now we're going to check that. We're going to check that answer. If you want to check it into your radical form, that's okay too. I know I always say the original. So 4. So if I put it into the original, so we are going to have the square root of 4 cubed equals 8. Does it matter what order I do it in? Whether I root it or I cube it? The answer is no, it doesn't. So you could do this, or you could do the root of 4 and then cubed. What would you tackle? Would you do the first one or the second one? Thoughts, feelings, anybody? Jessica, do you have some deep-seated feelings on which one you would do? Okay, well then you have to listen to what I would do. I'd do the second one. Does anybody know what 4 cubed is off the top of their head? You might, because you could have a good understanding of it. I always get the numbers smaller before I do any exponents to them. But like this would be 64, the square root of 64 is 8. Everybody knows what the square root of 4 is, right? 2. So I would do this one just because I get my number smaller, and then I'm going to cube it. But you're not wrong to do it this way if you wanted to. So x equals 4 is a good answer. This one just would have been square root of 64 equals 8. So 8 equals 8. Like you get the exact same check. But if you're doing it in your head and you want to go a little faster, if this works, I always do my rooting before I do any exponents. Okay, here we go. We need to isolate the radical. Now, I'm going to make my radical positive, but this is what I've seen. I've seen this plus root 2m plus 3. No, I'm lying. That's what I would do. But what I've seen here is minus m minus m. So I'm going to have a negative 2m plus 3 equals negative m plus 6. And just the danger with that is there's so many negatives that can be forgotten or left out. So I don't I wouldn't do it that way, just because I know me and I'm gonna screw it up. Or I'm gonna forget that the m is negative, which I never ever do. So I try to be consistent with what I'm doing. So I wanna make my root positive. So I'm gonna add 2m plus 3 to the other side. I know I'm moving two things. So I'm gonna have m equals 6 plus 2m plus 3. I want to isolate that radical, so I'm going to minus 6 from both sides. So I'm going to have m minus 6 equals 2m plus 3. Could you have done this all in one step? I think I would be fine to do that. I know when I move this to the other side, it becomes positive. When I move this to the right-hand side, it's going to be negative. So I could have went from this line to this line. And I think most of you could have done that. And that's fine that you don't show me the steps. Okay, so now step 2, I'm going to square things. Because there is just the root sign, there's no binomial, there's no constant, I'm not adding or subtracting anything to it, there's no coefficient, I'm good to go ahead and just cancel those out. So I'm left with m minus 6 times m minus 6 equals 2m plus 3. So I'm going to multiply m minus 6m. And as soon as I see that squared, I know I'm going to have to factor. So I'm emotionally preparing myself for that. So if I know I'm going to have to factor or use my quadratic formula, I'm going to set everything equal to 0. So minus 2m from both sides, minus 3 from both sides. So I have m squared minus 14m plus 33 equals 0. I can factor it. 3 and 11. So m squared minus 3m minus 11m plus 33 equals 0. So I'm looking at those two. I'm running out of room. So I have m minus 11 and m minus 3 equals 0. And so my two answers are going to be m equals positive 11 and m equals 3. And then that last step is going to be to check my answers. So even though this one looked a lot nicer than the single page one, the one that we had to do it twice, sometimes the simplest ones have the most complicated, these weren't super complicated answers. Like the other one was really easy to solve. So just because the question looks easy doesn't mean it will be all the way through. And just because it looks hard doesn't mean that it's going to make you cry. I think the thing that I screw up the most with is that I put the wrong values in here. I forget that they're both m and they both have to be 11 if I'm checking that. So 11 minus 22 plus 3 equals 6. Okay, so m11 is a good answer. M equals 11 is a good answer. Oh, this is silly. I'm just going to do it up here. And so people go off this one and they're like, oh, that starts with 11. Nope, the equation started with the letter m. So this is going to be a 3 here. That's a super common mistake. So that one's false. Did I do that right? I did that one right. That's right. So we are going to reject the m equals 3. Okay. I think that's it. That is it.